Hello students, today we are learning about ellipse and hyperbolas. So we are learning once again about ellipse and hyperbolas. So we're going to go ahead and look at our conic sections we have here. The two we're looking at today are these two right here. And we're going to first by talking about ellipses with a center at the origin, 0, 0. So when we have an ellipse at the origin, our formula looks like this. And for HK, on the very next page, it looks a little bit different. So an ellipse can be thought of as a set of points in a plane such that the sum of those distances of those points from any two fixed points is constant. So each of those points is called a focus. The plural of focus is foci. The midway point is the center. So we have our A value squared and our B value squared. Okay. When we have an ellipse with the center HK, the graph looks more like this. So this is the primary source we're going to be using here when graphing ellipses. In fact, I'm going to go ahead and zoom so it's half on the screen so you can see. And I'm going to start with example 1 so you can see with our formula. So if you notice, we're going to look at what value we have for our numbers. So this is really A squared and B squared. So this 4 is in fact really, let me switch colors. This is really 2 squared, and this is really 3 squared. And we know that we actually have a center here, x minus 0 squared over 4, y minus 0 squared over 9 equals 1. So what we have here is we know that our center of this ellipse is going to be at the origin 0, 0. So let me graph my center. Then from that center, I know that my x-axis is going to move by 2. And my y-axis is going to move by 3. All right, so 2, 2, 3, 3, push and hold. Should graph the ellipse for you. Might be a little crooked. You might need to draw it out a little bit better. There we go. Okay, now you might be asking what are your vertices and co-vertices? So our center is 0, 0. Our vertices are going to be the points that fall on our longest axis, if you will. So our vertices and co-vertices. So in this case, our vertices are going to be these points. Let me go ahead and mark them with pink. And our co-vertices are always going to be on the smaller side. Oops, I'll just switch colors. So our vertex in this case is going to be the longer length right here. So my vertices are going to be 0, negative 3. 0, 3, and my co-vertices are going to be negative 2, 0, and 2, 0. Okay, and that problem is done. That was it. We did it. All right, continuing on. Let's try another one. So the center here is going to be HK. So we're going to have our center at negative 3, 2. So negative 3, 2. There's my center. And now I'm going to look and I'm going to say, oh, this is 5 squared and this is 6 squared. So my x-axis, that's my left and right, I am going by a gap of 5. And my y-axis, I'm moving by a gap of 6. And this ellipse is actually quite large. Oops. Kind of got to draw the shape as an ellipse first and then go ahead and expand. Get all your points in the right spot. And there we go, an ellipse. Okay. My vertices are still going to be on the longer end. So my vertices are going to be these points here still. And my co-vertices are going to be these side points here. So my vertices are going to be my, let's see, that's negative 3, 8 and negative 3, negative 4. And my co-vertices are going to be negative 8, 2 and 2, 2. Once again, I'm labeling the orange and the pink. Okay, so those are my ellipse. Continuing on, we have some standard forms. So we're going to have to do things to these standard form. We're going to have to rewrite them. So first for C, I notice that if I divide both of these, all of these, by 36, what's going to happen? Well, 4 can go into 36, and 9 can go into 36, and 36 can go into 36 to equal 1. So I have y squared, so x squared over 9 squared over 9 and over 4. Oh, my eraser. Uh-oh. 4. Okay. And from here I can tell my center, 0, 0. And then I know that x is 3 squared and y value is 2 squared. So my x-axis is moving by 3. And my y-axis moving by 2. Okay, now I get to connect up the circle here. It's really an oval, right? An ellipse. And my vertices, once again, are going to be on the longer side. And my co-vertices are going to be on the shorter side. So my vertices here are going to be negative 3, 0, and 3, 0. And my co-vertices, 0, 2, 0, negative 2. All right, last one to try here. Ready? So this one we are going to have to require, it is going to require doing a little more effort. We are going to have to combine our like terms. So first, let's go ahead and reorder 3x squared minus 12x plus y squared equals 18. And I always want my c value kind of by itself. So I can complete the square with this first set. Factor out of 3, right? Y squared, I don't need to complete anything with it. But with this set here on the left, I am going to need to complete. And this would be x squared minus 4x plus, this would be 4, right? So I need to really add 12 because it's 4 times that 3 to the other side. What you do to one side, you must add to the other. So this is 30. And this is going to be 3 times x minus 2 squared plus y squared. Okay, if I divide everything by 30, and I'm not quite done, I know it's not a circle, because that would mean I have both squared. Okay, so plus y squared over 30, and x minus 2 quantity squared over 10. All right, so good news is we're done. Bad news is that these are not very nice numbers, right? The square root of 10 and the square root of 30. What? Square root of 10, square root of 30. So I'm actually going to bring up my little calculator here to help me out. Where'd it go? All right, let's see. Bring up my calculator, if possible. And I'm going to find my square root of 10. Sure, we'll use Desmos. So let's see, square root of 10, and that gives me approximately 3.1, so 3.2. And square root of 30 would give me approximately 5.5, we'll say. Okay, so your center of this graph is at 2, 0. 2, 0. Your vertices are your x-axis is moving 3.2, and your y-axis, 0.2, your y-axis is moving 5.5. All right, so when I connect these curves here, make sure I line them up. Yep. One, 2, 3, 4, 5.5. 1, 2, 3, 4, 5. Oh, 0.5. That point is too low. I have to move this point down. There we go. 5.5. All right. Okay, so let's see what points we have. We have approximately vertices would be square root, and in this case we can actually write out as square root. So square root 10, so this one right here, at 3.2 away, so we could write this as approximately 5.5 comma 0. We could write the other one as negative, let's see. Oh, that's not 5.5, that's 5.2 comma 0. The other one at negative, what point would this be? 1.2 comma 0. And actually, these are our co-vertices because they're on the shorter side. Vertices are the longer. So vertices would be 2 comma, and then 5.5. And 2 comma negative 5.5. So there's your vertices. There we go. And your co-vertices. Okay, this one's done. You can also, if you want, write this as square root 10, square root 30. Right? Square root 10 is gonna reduce. So this would be technically 2 plus. So the other way we would write this would be 2 comma, and then instead of saying 5.5, it would actually be 2 plus square root 10. 2 comma 2 minus square root 10, right? So if that's easier, you're welcome to do that. Co-vertices, you're going to do, let's see, you do, oh, put them in the wrong spot again. 2 plus square root 30. And you should be 30s here, sorry about that. Square root 30. Square root 30. So 2 comma just square root 30. 2 comma square root 30, 2 comma square root 30. There. All right, and then 5.2 comma 0. This would be 2 plus root 10 comma 0. 2 minus root 10 comma 0. Apologies for the confusion. There we go. Vertices and co-vertices. Okay, these ones are done. Go ahead, check your answers. We're going to keep going. All right. Hyperbolas. When we get to hyperbolas, we're going to have to look carefully at these. And for hyperbolas, we're going to graph each of them. So notice our vertices are going to look different, and our we're going to graph always on which one comes first. So if x is first, we graph on the x-axis. If y comes first, we graph on the y-axis. In terms of labeling your numbers, they're exactly the same. So this corresponds to x, this corresponds to y. And you'll notice they look like ellipses in terms of a formula. The difference is the plus or minus sign in the middle. That makes a hyperbola. So this would be 3 squared. This would be 6 squared. So in this case, my center is 0, 0. It's my center. My x-axis moves by 3. And I'm going to put a dashed line this time. And my y-axis moves by 6. So I'm going to put, once again, a dashed line to show these. Okay. I'll put dashed line. Okay, the way we graph these is we actually are expected to connect from end to end here, like this, and connect from end to end here, like this, just coordinate points end to end. Okay, this is how we know how to graph our hyperbola. And actually, we're going to label these lines on our asymptotes, y equals. So let's count them out. This is using all of our skills. So this one right here, if I'm counting this out, this would be y equals, and let's see, I got to find my slope. So if I'm counting, it looks like my slope goes across all of these, right? So up 2, right 1. And for the opposite asymptote here, y equals, I would say I'm starting and I'm going down to right 1. So y equals 2x and negative 2x. My vertices now and co-vertices. So when I draw, I got to draw my curve. So the way we're going to graph this is you're always graphing on either your x or y. In this case, x came first. So I'm graphing on the x-axis. And I'm really just getting close to these asymptotes. But I'm not going past them. So these lines that I have in the middle, they're actually my asymptotes. And they help guide my graph. So let me go ahead and make these all dashed lines because they're asymptotes. There we go. So that's my curve. That's how I graph it. It's a little complicated, but we're going to keep going a couple more just to practice. So my vertices are always the side that I graph on. So my vertices here would be negative 3, 0, 3, 0. My co-vertices would be the opposite. It would be here and here essentially. So 0, 6 and 0, negative 6. All right, let's try another one here. Graphing. So divide both sides by 25. Divide by 25, divide by 25. So I'd have y squared over 25 minus x squared over 25 equals 1. So this is really 5 squared, right? So my center is at the origin, 0, 0. Then from there, I'm moving 5, 5, 5, 5. And you might be wondering, oh no, how do we know where to graph this thing? Because if we look, my asymptotes come through the middle, but these asymptotes are going to be dashed lines, right? So I can label those asymptotes. So that's 1 over 1. This is just y equals x and negative x. Okay, so this one's y equals x. To be clear, this one's y equals negative x because it's slope of negative 1. So now how do I graph? Do I graph on the x or the y? Do you remember what I said earlier? We graph on the variable that comes first. So y, in this case, we're graphing on the y. You're going to get kind of close to where those asymptotes would eventually hit. And if you want, you can extend this dashed line to see kind of like where is your asymptote, where's your barrier, essentially. To kind of pause and graph like this and graph like this. There we go. So my vertices are going to be 0, negative 5 and 0, 5. My co-vertices are the opposite ones. So 5, 0 and negative 5, 0. There we go. Okay, we got 2 of them. Whew, we have the standard form coming up. And then it's practice time, right? Almost. Okay, so another one. Here we go. We're going to graph these. And when we go about graphing these, here we go. Actually, maybe I'll have you try this one. You guys try this one. See if you can put it into standard form. Go ahead, pause the video. See if you can try it, and I'll reveal answers. Go ahead, try both of these real quick. All right, thanks for coming back to us. I'm going to reveal the answer. Dun, dun, dun. So if you don't have it, you can go ahead and freeze your screen if you would like so you can see them. These are both our answers. The asymptotes for this left one was a little bit tricky to label, so go ahead and check, see if you got it right. The asymptotes were a little bit of a challenge. Okay, example 3 coming up. We are going to have you do each of these. So let's grab one of these and practice. So notice I didn't tell you what it is, ellipse or hyperbola. So let's see. If we graph x squared plus 2x plus 4y squared minus 40y equals negative 85. Then I group, right, x squared plus 2x plus 1 plus 4 times y squared. This is minus 10y. I need plus something, right? So how would I complete this square? Let's think about that. I would divide by 2 would be negative 5. Squared is plus 25. So on the right side here, I'd be adding plus 1 and then plus 100, right? So x plus 1 quantity squared plus 4 times y minus 5 quantity squared equals, and let's see what we got, 100 minus, or actually it's 101, right? Minus 85, oops, no, it didn't do that. 101 minus 85, survey says 16. All right. So we're going to divide. Can we tell what shape it is yet? Almost, right? It's not a circle. It's going to be an ellipse or hyperbola. Let me write it over here. So x plus 1 quantity squared plus y minus 5 quantity squared over 16 over 4 equals 1. All right, so square root here is 4, square root here is 2. My center is negative 1 comma 5, so negative 1 comma 5 is right here. And this is an ellipse. How do I know it's an ellipse? What do we think? Because there's a positive, right? That makes it an ellipse. Okay, so my x-axis is moving by 4. My y-axis is moving by 2. Connect the circle. Well, connect the ellipse. Apologies. I'll use the correct term. Call it an ellipse. There we go. Got it. Yeah. Okay, go ahead and check your answers. See what you got right now. I'm going to have you go ahead and do the other 3 and try this out. There's a lot of like you time. And I am going to show the answers. Don't worry, I got you. So you try to do these 3. Pause. Go ahead and work. All right, I'm hoping it was okay. I'm going to show these answers just so you can see it. You don't need the foci, but just that way you have the curves of everything. So just that way you have the curves of everything. And if you notice, there we go. Just to be clear, your center was here. And your center was also, oops, it shifted 4, 0 right here to be clear. Okay, and I crossed out the foci. You don't need the foci. Everything else you should have. And see if you graphed it correctly. So your vertices, right? X minus 1 squared plus, minus, and you're going to have y negative 1 squared and 5 squared. Oops, sorry. And your asymptotes are going to be y equals negative 1/3 x minus 2/3 and y equals 1/3 x plus 2/3. So for your asymptotes. Okay, go ahead and start on your partner activity. Here it is. I'm going to go ahead and scroll and show these answers just a few minutes. Feel free to pause. Great. Thanks for coming back. Here is your work. I have to cut this video short, but I do have answer keys for everything. If you would like the full answer key with solutions and all the steps, not just the final answers, I will share it with you. Just shoot me an email. Okay, sounds great. Bye, guys. You can start on homework now. Bye.